All right. Now, I want this section to be more of a preview than a review. Now, these are mathematical concepts that you should have learned or you have gone over back in Algebra 2. Now, most of us has forgotten, what everything we've learned in Algebra 2 anyway. But math is a language. Okay? It's a language of the sciences, particularly in statistics. Okay, and so what I want you to take away from this handout, right, is these are some, not all, but these are just some of the math concepts that we will be using. Most of it is it's just going to be language based. Most of it is going to be terminology, the technical skill or conceptually is not going to be that difficult. Okay, and once so for today, right, once you go over this, let's say that you're still unfamiliar with some of the concepts, don't be discouraged and don't worry. Like in later chapters, when we actually get to this, we will have another opportunity to familiarize ourselves with it. Okay, all right. Now, so first, we're going to use set notation. We're dealing with data sets and variables, and so set notation is going to be really important. Okay. Now in statistics, right, we'll adapt basic notations for sets that you learned back in algebra. So to represent a set of n numbers, we use curly brackets. Okay, so this is going to be really important, right? N here represents the number of elements, or in our case, more likely observations. So this will represent a set of n elements. Okay, like for example, if I have curly bracket, if I have x1, x2, x3, x4, then this will be n equals 4. This will be a set of 4 elements and 4 observations. Now, n could be either finite or infinite. Alright. Now, for our case, we're going to assume that n is going to be always going to be finite, where we're not going to conceptually we don't have to deal with infinity. So don't worry about that right now. Okay. So for example, right, here's a set of 5 observations or 5 elements, and correspondingly here are the numbers. And then you just want to practice reading the set. Right? So for example, x2, right, would be the second element, so that would be 4. Right? x5, right, that's be the 5th element, that would be 3. Okay, and we can use different letters to represent different variables. So this is variable x, this is variable y, and this would be, so for example, y3, right, will equal 3. Now, I will also say, we're going to take some liberty when we write these set notations. We're going to take some liberty in interpreting what the writer intends. So for example, I have y1, y2, y3 all the way to yn, so dot 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 yn. And if I see this obvious pattern 1, 2, 3, that means I can imply that, or this implies that, for example, y6 will simply equal 6. Right? We can assume this sequence. Okay. All right. Okay. By the way, let's say let's come back over here to this. Right. So x to the or x6, right, will equal. Oh, there's only 5 elements. There is no x of 6. Right. So then there will be nothing there. Now we don't write 0. Instead, we write this symbol. Okay. Now this just means nothing, or we call it null. Right. It just means nothing. There's nothing there. Okay. Now, these numbers, quote-unquote numbers, could be in tuples. Okay, this is it's called tuple. Tuple doesn't mean 2. Tuple just means a pair or sets. It should really mean sets. Okay. Now, so here I have 1, 2, 3, dot dot dot, all the way to n. So here again I have a data set of n observations. Okay. However, now there are 2 variables. So for example, you can say this is a height and income, let's say, right? Or height and shoe size, right? And so y could be the height and x could be the shoe size of every individual. Right. And you just want to be able to read from this, right, from this. So we're going to be, and this is why curly bracket and parentheses are going to be really useful for us to distinguish. Curly bracket tells us the whole set. The parentheses give us each tuple, each observation. So we can write this. So obviously this one here, y1 equals 3, x1 equals 2. Okay, and then you would just infer the order from the previous notation here. All right, and so if I just want, okay, well, what is y3? Y3 then would be 23. Okay, and then y sub n, this is the last one. Y sub n will be 13.5. Right, this is the last observation, right, of y. All right. All right. Now, summation notation. So this typically is the trickiest, and technically this, or technical wise, this is one of the hardest concept that we're going to be reviewing and be using. So don't worry, we'll have plenty of time to come back to this. I'll just give you a little bit of preview now. Right. So here again, here is our tuple. Right, here's our tuple, and now I have it written now. So I have a size 4. So n equals 4 here. Okay, you want to see 1, 2, 3, 4. I have 4 observations. Okay, now what is summation notation? So I'll just give you the definition first. Summation notation is illustrated by the Greek letter sigma. This is a capital sigma, and typically we have an index called I equals, and I will start at 1, and then we'll have an n here. Let me just write it down, and I'll tell you what each component is in a moment. Now, this is a summation notation. Here is the starting count. Okay, and then this top part here tells you the end count. Okay, and this inside here, right, anything with an I is the one that's counting. Okay, let me give you an example. Let me write this out. So for example, right, I is 1 right now. So then you're simply, right, you simply take whatever's inside here, okay, whatever's inside the summation notation, and replace the I with whatever the count is at the moment. So right now is 1, so this would be x1, okay? And there's nothing else in there. We've finished writing what's inside the summation notation. Then we count up. Now I is 2. Okay, and then we just replace that I with a 2. Now, summation notation, it's called summation notation is because we're adding everything up. So this would just be plus x2. Okay, now, what's after 2? 3. So it'll be plus x3. And then, when do I stop? I stop till I get to n. Okay, now we're going to leave n as a variable right now. So just dot, 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 and then we're going to go to xn. Okay. Like for example, right? I have a summation notation, xi to 3, okay? So this would be x1 plus x2 plus x3, okay? And I stop at 3. Okay? Now, how do I use this? Well, if I have a data set like so, right, then I can just pick out what what is x1, x2, x3. I simply just read off the table here. x1, look at my data set, it's 21. Right? 21, 13, 17. Right? Add all that together, I get 51. And that's what summation notation is. Summation notation, just think of it as a very shorthand, very compact way of writing a set of procedures, a set of summation procedures. Right? I'll give you one more. Let's see, summation. What about if I just have summation I? Right, to 3. Right. Again, don't overcomplicate it. Keep it simple. I is 1 right now, so I just look inside the summation. I is 1. I just replace the I with a 1. That's 1. And there's nothing else there. I move on. What's after 1? 2. Add 2, because now I is 2 now. And then after 2, I becomes 3. Now I is 3 now. I stop at 3. Okay, and that's it. Okay, so that would be 6. Right? I can do the same for let's say for, I can do the same for y. Okay, so summation I equals 1, right? Let's just add the 2 here, yi. Okay, and so I'm going to be referring to my previous data set here. So this will just be y1 plus y2. Okay. When in the beginning, when you're reviewing and you're practicing this, I recommend just writing out what the summation looks like, and that way. And then from here, then it's much simpler. You can just plug things in. 0.54 plus 0.65. Okay, and that would be give us 1.19. Okay, now I can also do something a little bit trickier. Like for example, I can do summation. Let's just go to 3 again. I equals 1, right? And then I'll put a 4 in the front. 4 times xi. Okay. Again, it looks, so I'm adding this constant 4, but just focus on every time when I write, a term here, right? I'm just gonna have a 4 in the front, and maybe try this, right? Try if I have from 1 to 3, I know that I'm going to have 3 terms, so I can just go ahead and put in the parenthesis here, okay, and this will help. This will help you visualize it. You don't have to do this every time, of course, but for now, right, when you're practicing, you can go ahead and try the parenthesis here. And then, so this will tell you, well, I have a 4 times x1. So this will be 4 times x1 plus 4 times x2 plus 4 times x3. Okay. All right, and then from here, just fill in what x1. Again, look at your data set here. Look at your data set. So fill it in. What that is. Four times 21 plus 4 times 13 plus 4 times 17. Okay. Now, once you see that, you can see the remember from your algebra, I have a constant 4 here. I can factor that out. So I can just take, right, this will just really just equals 4 times, and then 21 plus 13 plus 17, which I know what that is already, because I did it earlier. And that'll be 4 times 51, which will give us 204. Okay. Okay, feel free to pause the video and give these two a try. Okay, and then when you're ready, start the video again. All right. So let's write this out. Okay. Summation 2, I equals 1, yi plus 2. So this is just going to be, and look, I have from 1 to 2, I know I'm going to have 2 terms. So you can go ahead and put a parenthesis there. Right? This will be y1 plus 2, y2 plus 2. Okay, which will equal 0.54 plus 2. Oh, by the way, for convenience, I copied our data set that we're going to use as example right down here. Okay, so you don't have to flip the page over to take a look at it. Okay, and then this one is a little complicated. Now, let me write it down here again. I equals 1 to the n x I y I. Now, where do I stop? Right? Because I have this notation, I then put a number here. Okay. Well, as a rule, right, and this is just the standard convention. If it's n, then this just stop at the end of the set. So in our case, our data set has 4 elements, 1, 2, 3, 4. Then we will simply stop at 4. Basically, the whole data set. That's what n is. When I do the I equals 1 to n, they'll give us the whole data set. Okay? So, and now xi times yi, that's basically is telling us to take the 2 variables, right, for each observation and then multiply them together. And then we add them all up. Okay, I'm going to go a little bit quicker. Okay, so let's write them all out, multiply them together. By the way, this operation is called sum product. Right? And at this point, just go ahead and use your calculator, and when you get it all done, you should get this number. By the way, just fair warning, this is a common mistake, and I'll just write it out here. This does not equal this. Okay, just fair warning now that this is not a thing. Okay, I see this a lot in previous semesters. Students like to make the same mistake. So basically, to calculate this, you have to do it this way. You cannot just add up all the x values and then add up all the y values and then multiply them together. That's not going to work. In statistics, we're going to adapt a set of commonly accepted notations. Okay. Now we'll call this bar. So anytime when you have a variable and you draw a line above it, we're going to call that bar. So this, for example, is called x bar. Okay, and anything with a bar over it will have a very specific meaning. It just means the average of x. Okay? And this would be the arithmetic average of the set of numbers. Okay, so, and you all know, right, how to take averages. You've done it many times, right? X bar, so then just means you add up all the x values and then divided by n, right? Okay. All right, and now here, right, we're going to introduce another shorthand. Okay, so notice I said earlier that if I have summation ni equals 1 of xi, right, and then notice that if I don't specifically write a number here, then that means add up the whole set. Okay, all right, this is the entire, so this add the entire set. Okay. Now, because we're going to be doing this operation so often, right? That and we are lazy people, so we don't need to write this every single time. And so then, a lot of times, then what you will see is this. Okay, you see this in the textbooks, also sometimes in my notes as well. You just see the summation xi. Okay. Now, if nothing is here on the bottom and on the top, it is implied that we're starting at 1 and we're going all the way to n. It is just simply it's a shorthand to imply that we're going to simply be adding up all the x values. And same thing as the y, right? If I have summation n I equals 1 of yi, right, then this is equivalently, I can just write it like that, so save ourselves a little bit of effort. Okay. Now, okay, so then, like for example, right, what about y bar, right? Well, doesn't change, right? In the entire field of statistics, where anytime we see a bar, right, we know what to do now, right? You just add up all the y values, and then divide it by the entire data set, or sorry, the number of observations. Okay, and so for example, let's go ahead and give that a try. Right? Summation yi. So then just by the way, I'm still using the same example as before, so this is previous data set that we have. So then we just go up to y4 because there's only 4 observations. Okay, divided by 4 because there's 4 elements. Okay, write that out. Divided by 4, and that's going to get you 1.4725. Okay, go ahead and try that in there. And at this point, you're going to be using calculator for all this work. Okay. By the way, just a couple of quick algebra or arithmetic tricks. Right? For this, the y bar, I can also rewrite it like this. Right? This might help with your notation. Just makes things a little bit cleaner if you need to. So what that means is I can write this as 1/4 times 0.54. Right? Right? And depending on the context or where you're writing it, this might be a little bit cleaner. Either way, the end result will be exactly the same. In mathematics, and therefore in statistics, we have this thing called identities. Now, identities, you just want to think of it as another shorthand, right? The previous, what we saw earlier, this bar idea, right? This is an identity, right? X bar, right? It's just a shorthand way of writing this whole complex thing. Right? X bar is an identity. Okay, so we're going to be using this a lot in statistics. Okay, and one of the more complicated identity that we will be using a lot is this thing called the sample variance. Okay, and so this is one of the more complicated identities. Then I thought we just kind of practice it out of context here. So let's not worry about what is a sample variance. Right? Conceptually, let's not worry about it. Let's just figure out how to calculate it, and let's use this as a way of practicing how to write, how to deal with identities. So, sample variance, we will write S squared, right? And again, that's just shorthand. So when you see that, then you just have to look it up. You just have to just try to remember, okay, well, what does S squared mean? What is the identity of S squared? And S squared is, here we go, is summation xi minus x bar squared all over n minus 1. Okay, so that is the identity of the sample variance. Okay, in later chapters we will discover conceptually what that really represents. Okay, but for now, let's just focus on the math of it. Okay, so look at that, and you're trying to see, okay, I have this data set. How do I calculate this identity, right? And looking at that, and at first, right, it might look complicated. So what I suggest is write out the first few terms. Right? You write out the first few terms, and then so you get an idea of what this identity is. What this identity is. In a way, we're just gonna be expanding it, right? So I remember I have nothing written here on top and bottom, so that means I'm going from I equals 1 all the way to n. Okay, and inside my summation notation here, the only thing that changes is the I. So I starts at 1, then it's just x1 minus x bar squared at plus x2 minus x bar square, x3 minus x bar square, and so on. And since I don't have an endpoint, I'm adding it all the way to the end, right? Well, in this case, I only have 4, so let me just go to x4 minus x bar square, like so. Okay, and then I'm done with the numerator. Draw a line, and on the bottom, it's just n minus 1. In this case, it would just be 4 minus 1, so, or 3, okay? This is sample, right? So this is sample variance. Okay. Now notice here I just assume x, and by default we typically assume x. However, in our data set we have more than one variable here, so we're gonna need to use subscripts to distinguish between them. Okay? So then what I should have written above. Right? What I should have written above, given that my data set has both x and y in it, then I should use subscript. So here, if I have sample variance x, this means then the sample variance of x, right? And so that will be summation xi minus x bar squared over n minus 1. Okay. Now if I write then s squared of y, then simply naturally it will be yi minus y bar squared over n minus 1. Okay. All right. Now, okay, and then the rest, right, would just be, it's complicated, but the rest would just simply be plugging it in. What this is saying is you take the first term minus the average, right, square it, plus second term minus the average, square it, so on, and then divided by 3. We'll do an example now, okay, and I think they'll become much clearer. Okay, so find S2 of x. Right? All right. Now, whenever you calculate variance, right? Whenever you calculate variance, what I suggest, right, regardless of the size of your data, is I suggest the table method. Okay, because you notice here, I have to do a couple operations. I have to find the x bar first, and then I have to take each term minus the x bar, the average, and then I have to square it, and then I add it up. Right? There's a couple steps here, and using a table is going to help you organize much easier. Okay, so here's how the table method will work. Okay, first I have a column for xi. Okay, that means I'm going to write down all the value of the variable. Okay, so look above at the data set. I'm going to write down. So we write down all the values here. Okay, that'll be my xi. Next, I need my second column will be xi minus x bar. Okay, I'm going to subtract x bar, the average, from each of these. Now, so then in that case, then you need to find x bar first. All right, so I already did that earlier. Okay, but you would just simply do that on the side, do it in the calculator. Right? But if you did that, then what you will find is 18.5. Okay, so that's x bar. Okay, and now so you just simply take each of them. So you take 21 minus 18.5, 13 minus 18.5, and so on. Okay, and so if you did that correctly, this is what you will get. Okay, next, all right, remember I'm following along the identity. I'm just simply following the identity here. Next step, I want to square it. Okay, so this column will be xi minus x bar squared. So we take everything in this column, then just put it in the calculator and square it. Now, remember your simple arithmetics, right? When you square anything, it always becomes positive. So you should not have any negative number here, right? Because the negative 5.5, right, when you square it, is the same as 5.5 squared. So in your calculator, maybe just leave out the negative altogether. Okay. Now, I have this column here. Then what I want to do is simply add it up. So if you put that in a calculator, you add that all up, you should get 59. Okay, and this portion is the summation xi minus x bar squared. That's the numerator part. Numerator part there. Okay, not quite done yet. Right? I still need to find the sample variance s squared of x. Okay. So I have that. That'll just be 59. And then I divide it by n minus 1. So that will be divided by 3. Okay, this is the n minus 1. So that 4 minus 1, 3. And divide that all together, I get 19.667.